Hello? Someone say something so I know my audio is good.
You're good.
Hey.
Good.
Cool.
Did we have a quiz before class today?
Mila, can you hear me?
Right now I can.
Okay, great. Everybody else, is everybody else hearing me?
Yes.
Yes.
I can hear you.
Okay, I'm sorry. Nobody was answering me.
I can hear you.
Yes, Mila, you had a very hard quiz that you had to do.
Was it the pop quiz?
Yes, it was.
Okay, I thought it was quiz 12 and I like tried to do it last night. I'm like, it says it doesn't open until like noon today, so I don't think that's it.
No. Quiz 12 is due on Monday. Or
Okay,
Sunday, no, Monday midnight.
all right, just wanted
Okay.
Where cowboy get?
to. Did you hear my son just asked where'd the
What?
cowboy go? Cause your hat. That's funny.
Sorry, guys. To be honest with you, what happened was you wiped me out on Tuesday night. I literally had a lot of pain on Wednesday. So basically, I'm in bed right now. And I didn't figure you wanted to see my dirty sheets. Let's see. I want to hear somebody else out here. Jennifer, Apple Grace,
Yes.
Hunter,
Hello?
you're all hearing me, right?
Yeah.
Yes.
Okay. All right. Any complaints about the quiz, the pop quiz?
I
You
think
know,
it was
you
still
really,
the wrong date.
you really
What's that?
went down
I
memory
saw-
lane there.
I still think it was set for the wrong date, but
What did I say
Yeah.
it was set for?
you told us on Tuesday that you
I
were going to
gave
make
you a
it
due
Thursday.
date. Victoria, I gave you a due date. I
Okay.
did not give an until date. The until date's the important one.
Yeah.
If I tell you,
Okay.
if I give you an until date, that means you can't access it after that date. If I give you a due
Oh, okay.
this means this is when I want it. It doesn't necessarily mean that's when I'm going to get it.
So when is it due?
I'm sorry. Spencer, it was due. It was due last night, I believe, at midnight.
Oh,
Spencer,
yeah.
have you done it yet?
No, I haven't.
Did you just listen to what I said?
Sort of. I'm sorry. I was somewhere else.
I was
Spencer,
watching doing it yesterday.
Spencer, there is a due date on it, Spencer.
Okay.
However, there is no until date. Actually, there is one, but it's like May 10th or something like that.
Yeah, it says May 1st.
May 1st.
So you have to do it. All right, please do it this week. And
Okay.
email everybody that has not turned in the pop quiz to this date. Please email me that you have done it because I need to grade those individually. What this means, guys, is that you will not get your free 10 points if you don't get it.
All right.
Everybody have fun with it?
Yeah.
Yes. That was
Yes.
pretty cool.
I was
Time
thinking,
is kind.
Down memory lane.
yeah, the favorite pet one made me sad.
Hunter, I put down 5 dogs now. I know
Oh
exactly
my
what you
God,
mean.
dude, don't even tell me that. That's the last thing I need to hear.
I'm
But that's
sorry.
what, you know,
It doesn't get easier,
yeah.
but somebody sent me a card recently that was very, very apropos. And it's something to the effect of sorrowness means that your love has no place to hold. Okay. And I just thought it was very, very appropriate. I really, really enjoyed it.
It really is.
Yes. Okay.
Hey, I have a question about quiz 11.
Okay,
so you said
Elizabeth.
there was-
Where were you on Tuesday, Elizabeth?
Sick, throwing up.
Okay, good. I'm glad that you didn't, I'm glad you didn't display yourself to us. Okay, are you talking about question 10?
Yes, I got
Don't worry, it's already
100%.
fixed.
Yeah,
It's
that's
already
what I was going
fixed.
to ask. I saw the email and that's what I'm asking about. If you got 100% on quiz 11, how does that extra points add in? Or if you got 100,
There are
you're just
none.
not going to add.
Elizabeth,
Okay.
Elizabeth, you really want me to regrade your quiz? Because if I
No.
regrade your quiz, then you got the answer correct originally, right, Elizabeth? That was the
Yes.
wrong answer. So
Dang.
if you
I
really-
figured.
Elizabeth, if you really want me to go back and regrade it, I will.
No, that's what I was confused about. It's like, because I got one of the answers that was there, but something just didn't seem right. And then when I got 100 on it, I was so confused.
That the reason was I put the wrong answer was in the key. And I just went in and gave everybody credit for it. That's the thing.
Okay, thank you.
Anybody else have any other complaints about me? I usually don't get a lot of complaints the lecture after the pop quiz.
Yeah, what? I
Go ahead.
saying some of your stories are pretty hilarious. Like the one, the wax museum one.
Oh, my godson was scared. I literally thought I was going to have to buy him a pair of underwear in San Francisco. It was great though. I
That's the
still
best
do.
place to
I
do
still
that.
do that with little kids. We have a trunk or treat thing on Halloween, and I dress up as a scarecrow where I put a burlap bag over my head and I stand straight. And when they come to grab the candy, I come to grab them, and they get really, really upset.
It's like Jeepers Creepers.
Yeah,
Yeah.
isn't it though? God, if I didn't have a mean personality, I wouldn't have any personality at all. Are we ready to get started, ladies and gentlemen?
Sure.
Yeah, I apologize but you're not seeing my face because I am literally resting in bed. All right, share screen. Okay, how are you doing with these problems? Are you understanding them? These really
yeah.
are fairly difficult problems.
We're still practicing.
Yeah,
Yes,
this isn't I was working in the lab and getting better at it though. You just put the appropriate, units over each other and then you times it by whatever's in front and then bada bam, you know what I mean?
Yes, Hunter, that's exactly correct for the mole. But the problems we're doing now are more intuitive in nature.
Yeah, with the atoms, you just count up the subscripts and then
But Hunter, we're not dealing with atoms anymore. We're dealing with moles.
yeah.
We're comparing moles of atoms anymore, okay?
I've been doing the problems in the survival guide, and they're not bad yet. So I'm understanding it better.
It gets a little harder and a little harder and a little harder. The more of these
I already
problems
know.
you can do. Victoria, Dory?
Yeah, my coworker passed me today at work, and she's like, "You look a little more dead today than normal." I'm like, "That's because I'm doing chemistry right now, and this is really fooling with me."
Yeah.
Professor, I was working in the homework for the empirical formula, and there were a couple questions I had in there. I wasn't sure if we had enough information to find out what it was asking.
If they gave you the question, I think I'm sure that there's enough information there. Is this Jennifer?
Yeah. So like one of them was calculate the mass in kilograms of each
Jennifer,
compound.
are you in my lab tonight?
No, I'm on Tuesday.
Crap.
I can send it to you in an email if that
Do
works
that.
better.
Send it to me in an email. I'll look at it then, okay?
Sounds good. Thank you.
Yeah, I looked at that one too, and I was like, I'm gonna do this on Saturday, because
Which question is it? Do either one of you know off the top of your head?
it's like
I'm
the
looking
first
at it.
question. I think I don't know.
Jennifer's looking at it. Jennifer?
Yeah, so it's the very first one. So it says calculate the mass in kilograms of each compound that contains 6.5 times 10 to the third kilograms of iron. So it gives you iron oxide, which is hematite, it says in parentheses.
Okay, basically, all they're doing, they've given you the formula, right?
Uh-huh.
All they're wanting you to do you remember when on Tuesday, when we had the empirical formula and we found the mass percent of iron
Mm-hmm.
there? Well,
Yeah.
what they're doing is they're telling you that the big number of kilograms,
Uh-huh.
that's the number of the mineral, I believe. Then you figure out the mass percent of iron within that mineral and apply that to the big number of kilograms, and that should give you your weight of iron.
So we don't have to like convert them to kilograms. It's just
Oh, so it'd be like how we did with like the convenient number. Is that what you're in referencing to?
Convenient, no, not the convenient number. Okay, let me pull it up, guys. I'm gonna drop this down. It's
I'm
gonna
sorry.
do us, no, it's gonna do us just as much good as the other thing.
I mean, I think if we get a first example of like what they're looking for, then you can do like the rest of the problems in that.
Yeah, because I think the problem that I was having is in order to get like mass percent, you have to have the total amount that's there, right?
Mhm.
And it only gives you.
Well, you can do mass percent from the formula.
Oh, yes, yeah, that's what I was confused on then.
Okay. Is everybody seeing my Pearson thing?
No.
Stop share. Now are you seeing it?
Yes.
Yes.
Okay, all assignments. Homework 7, correct?
Yes.
Problem 1?
Yes, the first one.
Yes.
Yeah, are you seeing the screen yet?
It's still on the problems.
Okay, is this the problem you're talking about? Ammonia, ammonium nitrate, and ammonium hydrogen phosphate.
No, it might be scrambled.
I don't think it is.
Hold on. Because I looked at that one too.
It says on the top right that you're on question 6 out of 12.
Oh, yeah. So it's question 1 out of 12. You're on 6. Yeah.
Okay,
Valid.
let's try it again. All right. All right. Iron is, are we seeing the screen now?
Yes.
All right. Now, you have a formula here, right?
Mm-hmm.
Don't you remember we went through and were able to determine mass percents by the formula?
Sort of.
Okay. The mass percent of iron in hematite, I take the atomic weight of iron, which is 55.85. I got 2 of them. So I multiply that by 2. Somebody keep track of my numbers here, okay?
I'll do my best.
55.
Hold on. What do you do? So you take the atomic weight of the iron?
Atomic weight of the iron.
So that,
Yes.
All right, look, we're in part A.
Yeah.
We have Fe2O3. What we have to do is we have to get the mass percent of the iron in that molecule.
Mm-hmm.
All right, so somebody writes 111.7.
you got it.
All right, and there are 3 oxygens. So add, no, never mind.
Oh, wait, I think I know. Okay, I think what I was confused about was the number on the left side. If I had to use that, the two where it says 2.7.
Yes, you do.
Oh, I do? Oh, okay.
All right, so the entire weight of hematite
Hmm.
is 159.7.
Okay.
The weight of the iron is 111.7. So if I take the 111.7 and divide it by, what was that number I just gave you?
159.7.
159.7.
That gives me that iron is 69.94% of the compound in hematite. Well, if
Yeah,
that's what the iron
69.94.
percentage is, then all I could do is multiply that by 2.7 to the
Oh.
third. That gives me 1,900 kilograms of iron.
Okay. Okay. I'm
Oh,
confused on how to use that number, but I see how. Okay, gotcha.
See, this is the compound. This
Mhm.
is what the weight of the compound is. You figure out the mass percent of the iron in the compound, then apply that to the total weight.
And how much? Okay. Okay, gotcha. Yeah, I was confused on how to use that number, but I got it now. Thank
wait,
you.
what'd you get for the answer for it?
1,900,
Oh, okay.
because it's two sig fig story.
Yep.
Yep.
Okay, are we good with that? Anything else on homework?
No, that was good. Now we can do the rest of the problems because I was staring at this and I'm like, I got no clue.
All you got to do is ask, guys.
Cool, thank you.
Thank you.
Okay, we're going to get back to the PowerPoint. I believe, if I am not mistaken, and I might as well go through this one again. I believe this is the last problem we did. Is that correct? Guys?
Yes, I believe so.
Yes.
Now, do you remember the trick you do? Remember, when we're doing empirical formula problems,
Assume
first step is find the weights. Second step, turn the weights into moles. Third step, divide by the smallest number of moles. Fourth step, if you've got a fraction, get rid of it by multiplying by an integer.
for this one, wasn't the first thing we did was assume the weight was like out of like 100 grams.
That's exactly what you did. If you had 100 grams, then 26.57 grams of that is going to be potassium. 35.36 grams is going to be chromium, and 38.07 is going to be oxygen. So what's the next step we do, guys? We now have the weights. What did I just say our next step was?
Turn it into moles.
Turn it into moles. So I'm going to go to my periodic table. And Jennifer, I'm going to look at my periodic table, and I'm going to find out that potassium weighs what?
39.09
Or
or 39.1.
Yeah, 39.09. That's good.
Okay.
Okay. If I've got 26.57 grams of potassium, how do I get moles of potassium?
Do you have to multiply it?
Multiply it by 1 mole over.
The weight of the potassium, which is the 39.09.
Absolutely. Okay. Let me see who else I'm gotten in here. There we go.
A question. Can we just divide it by the atomic mass to
Yeah,
get?
yes. Maria,
Yes.
if you know it in the top of your head that in order to get the moles, you divide grams by the atomic weight, you're good.
Okay.
Okay.
So, Professor.
You're just skipping a step.
Okay. Thank you.
Professor?
Hunter, is that Hunter?
It's Chase.
Chase.
You take the 26.57 grams and then you multiply it by 1 mole over 39.09, right?
Correct.
Okay, I just want to make sure I was right.
All right. All right, Chase, you do the second one for me. You got 35.36 grams of chromium. How are you going to get moles of chromium?
You got to find the atomic number.
It's on, if you've got your periodic table, it's on the first line of the transition metals.
Mm-hmm.
55 something or 53 something
It's 51.9.
or 51 something. Okay. So Chase, you get me moles of chromium.
What's
You're gonna
that?
take, tell me how do you get the mole? You have 35.36 grams of chromium. How are you gonna get moles?
You divide 1 mole over the weight.
1 mole over the atomic weight, multiply that by the 35.36. And as Marie said, all you're really doing to get the moles is you're dividing the weight by either the atomic or molecular weight. That's all you're doing. In this case, we're using atomic weights since we're dealing with elements. Now, Hunter, you out there? Hunter went to get a snack.
No, I'm here. For some reason, it won't let me blow up the screen. Hold on.
No, Hunter, I'm hearing you.
Okay, can you hear me? Can you see me?
Yes.
All right, cool.
All right, if I have 38.07 grams of oxygen, how do I get moles of oxygen?
Okay, you got 38.7 grams.
0.07.
So we're gonna
0.07.
put the way I do it is I put 1 mole on the bottom part, like the denominator part, and on the top, pretty sure we put Avogadro's number.
No,
No, then we put the molecular weight.
Hunter, you want moles, okay? So if you want moles, moles is going to go on top.
Oh, so 1 mole on top
Over,
the molecular weight.
absolute. In this case, it's an atomic weight. And remember, guys, this is oxygen. A lot of times you're going to see oxygen as O2. Right now, we want the moles of atomic oxygen, not molecular oxygen. Empirical formulas, we're always dealing with the atoms. So I'm going to take that 38.07 and I am going to divide it by 16. I have done that on this slide. Okay,
right.
Marie, what do I do now?
Which one?
Are you seeing the slide?
Yes.
Okay. I've gotten past step 2. I've turned all of my elements into moles of my elements,
Okay. Now you're gonna get the smallest one.
which
to,
is,
0.68
okay. And what am I going to do with that 0.68?
divided by each of,
I'm going to divide the 0.068 into each one of them.
yes.
This gives me 1 mole of potassium, 1 mole of chromium, and 3.5 moles of oxygen for all intents and purposes. Do I have a fraction amongst the 3 guys?
Yes.
So how do I get rid of that fraction?
Times it by 2.
Times 3. If I times 3.5 by 2, I also got to times the chromium by 2 and the potassium by 2 to make sure I keep the same molar ratio. I do that, I end up with the formula K2Cr2O7, potassium dichromate.
So, Professor, if you find the mole under 1, it's just 1.
Whoa, I'm not understanding what you're saying.
Go back. No. So go back to slide 56, and then both K and Cr are 0.68 mole.
Okay.
So it would equal 1, right?
No, Chase, no. What you're doing, Chase, is you're taking each of these numbers, each of the mole numbers, you're finding the smallest number of moles amongst the 3 of them. That makes sense?
Kind of.
Okay, trust me, even if it doesn't make sense, do it anyway. Okay, when you get to the step after you've made all the moles, what you're going to do is you're going to find the one that has the smallest number of moles.
Mhm.
And that's either potassium or chromium. Okay, Chase?
Okay.
Then the next thing you do is you take that smallest number of moles and you divide it into the moles of each of the other elements, which is what I did in this slide. These are the amounts of the moles of each of the elements. This is the smallest number of moles.
Question.
Just one second. I want to make sure Chase has this.
Okay.
Chase, does that make sense to you?
Yes. Just
That's where the ones came from. It's not because we rounded anything. The ones came because we divided the amount of moles that we had by the smallest number of moles that happened to come out to be 1.
okay.
Marie, question.
Yes. For example, if we had 3.599, can we round up to 4?
No, that's much too far away. I would say if you're within 0.1 of the whole number, then go
Okay.
ahead and round. Okay? Like for example, if this were 3.899, right, Marie? I
Okay.
would just go ahead and round that to 4. Because it
Oh.
gets pretty ridiculous. The formulas get pretty ridiculous when you start multiplying them by an integer of 10. Does that make sense, Marie?
Yes.
But the other thing I would do, I would go back and check all your math because you may have done a calculation wrong.
Okay.
Okay?
Mhm.
When
Thank
you
you.
don't have anything that comes real close to it, real close to a whole number, then it's either you've done the math wrong or that you're going to have to multiply by an integer. Other questions, guys?
So to find the formula, if you go back a slide, yeah, it says use.
A multiplier if necessary.
When would it
Multiplier is
not
the
be
integer.
necessary?
If these numbers had all come out to be even numbers. If this were 1 mole of K to 1 mole of Cr to 3 moles of O, then my final formula would have been KCrO3.
I have a question.
Yes, Hunter.
Is there, like, at the beginning of the slides, is there a resource where it shows the formulas without the examples in them? Because I just want to print those out. You know what I mean? Like where it'll show.
Are you asking me to give you a listing of every inorganic compound known to man?
No, I'm not saying that. I'm saying like, you know, like the ways to set it up, like the blueprint of it. I'll try to find something online.
Somebody remember slide 60. Hunter, you see slide 4?
Yeah.
Is this what you're asking for?
I mean that's good, but I'm saying like, never mind. I'll try to find it and I'll
Well,
post it in the form.
Tell me what you're talking about.
Okay, so you know, in like the lab that deals with this, how the questions are set up to where it's like, you know,
You
something
haven't done this lab yet, Hunter. This lab's going to come up real soon, but you haven't done it yet.
Okay, but I'm saying I'll show you. I'll send something in the form. It's okay. Let's go back to slide 60.
Okay. A compound has an empirical formula of CH2O. It has a molecular weight of 180.19. Now, if I just quickly add these things together to get a weight of it, my empirical formula weight is 12 for carbon, 2 times 1 or 2 from hydrogen, and 16 for oxygen. I add those up, it's 30. That's what my empirical formula weight is. My molecular formula is 180. They don't equal one another, so the empirical formula can't be the molecular formula. Does that make sense to you?
Yes.
So, how do we figure this out? Okay. Remember when we were first determining empirical formulas? We had something like C6H6, right? And in order to go from the molecular formula to the empirical formula, didn't we divide the subscripts by an integer? We went C6H6, we divided all the subscripts by 6. to come up with the empirical formula of CH, right?
Yes.
Okay. Now, we know what our empirical formula is. If to get from the molecular formula to the empirical formula, we divide it by an integer, to go the other way, we're going to have to multiply by an integer. Does that make sense?
Yes.
Hunter, you're looking curious at me. You know, I'm not hearing you, Hunter. Somehow you're muted.
Yeah, I'm muted, but I just unmuted myself. No, I was looking at something online right here, like a stoichiometry flow chart.
Hunter, we're going to get to stoichiometry next. Please don't confuse the issue right now.
I'm not trying to. I'm just trying to find like conversion examples so I can print it out and have it for notes.
Okay, good enough. Everybody understand, when we went from molecular formulas to empirical formulas, we divided the subscripts by a whole number, right? So if we're going in the opposite direction, we're going to have to multiply the subscripts in the empirical formula by a whole number to get the molecular formula. So we figured out that our empirical formula weighed 30 grams by adding the atomic weight of carbon, 2 hydrogens, and 1 oxygen, right? Understand, we are not going to be changing the ratio of our atoms. It's still going to be 1 to 2 to 1, but there are going to be more of them. So I got to figure out what number I got to multiply each of those subscripts by in order to come up with the molecular weight. What I do know that my empirical formula weighs 30. My molecular formula weighs 180. So to do this problem, all I have to do is divide the molecular weight by the empirical formula weight. When I do that, I will get a whole number. When I get that whole number, I multiply all the subscripts by it.
Professor, just a quick question. The molecular weight of CH2O is 22, right?
No. Rosina,
Because it's C1H2 and O1.
yes. C weighs 12.01, right, Rosina?
Yeah.
For all intents and purposes, hydrogen weighs 0.01.
Yeah.
There are 2 of them, so that's 2.02, right?
Correct. Yeah.
So 12.01 and 2.02 is 14.03, correct?
Right.
Add 16 to that, you get 30.03.
So we should not be taking just O, we have to take O2.
No, I'm not. No. Rosina, I have to add 1
Oh,
carbon.
I'm so sorry. I was totally looking at something else. I'm so sorry.
No, there's no problem. Okay, guys. So what we're going to do, our strategy here, our molecular weight is going to be some multiple of the empirical weight. Whatever that multiple is, we're going to take that and multiply all the subscripts in the empirical formula by that multiple. We find the multiple by taking the molecular formula weight, dividing it by the empirical formula weight. Okay. And second. I figure out where I'm at in this thing.
Hold on. So for that question, all you wanted was the empirical formula, right? That's all you have to do?
No, you're given the empirical formula. This problem, Chase, is you are given the empirical formula and the molecular weight.
Mm-hmm.
What I'm telling you to do is add up all of the atoms in your empirical formula. That will give you an empirical formula weight. In this particular case, it's 30.03 grams. Are
Okay.
you seeing that,
Yeah.
Chase?
Yeah.
All right. If the molecular weight is 180.19, and I divide that by the empirical formula weight of 30.03, I get the number 6. Are you with me?
Yeah.
So I can't figure out why I solved this. 1 second. Okay. So I'm going to have to put a new slide in here because I don't know what happened to it. So I'm going to take my 180, divide that by my 30. And this is going to be equal to 6. Now, my next step is multiply all subscripts by the integer. And so my empirical formula was CH2O. What is going on? Back. Stop that. Ugh. I will get it, I swear. Part of the troubles, I'm working in the dark here. So what I'm going to do here is my subscript on my carbon is 1, right?
Mhm.
All I'm going to do is multiply that by 6.
Okay.
My subscript on my hydrogen is 2. I'm going to multiply that by 6. And my subscript on my oxygen is 1. So I'm going to multiply that by 6. I do that math out and I get C6H12O6. Are we good with that? Do we understand how that problem came about?
Yeah.
Yes. Yes.
Your strategy in doing molecular formula problems is you're going to be given the molecular weight. You're going to be given the empirical formula. Now, you know you have to multiply the subscripts of the empirical formula by some whole number. So what you're going to do is you're going to find the empirical formula weight by adding up all the atomic weights that compose the empirical formula. Once you get the empirical formula weight, divide that into the molecular weight. That gives you your integer. That is the number that you multiply all the subscripts by. Are we good with that?
We're good.
Yes.
Okay. This other things were. Okay. Another example, the molecular mass of benzene is 78. Empirical formula is CH. Guys, when you're doing these problems, this is an example where you don't have to be that picky about your atomic numbers. Just use 12 and 1 for the carbon and hydrogen. 12 and 1 is 13. My molecular weight is 7. The 13 is my empirical weight. So I take my 78, I divide it by 13, I get 6. Therefore, since my empirical formula subscript for carbon was 1, I multiply C 1 times 6. Since it for hydrogen is also 1, H 1 times 6. So I get my final molecular formula of C6H6.
Hey, Mr. P, I know you probably went over this already. How do we find that molecular weight? Was that?
Curtis, you're given. In that particular problem, it's given to you.
I thought that was the empirical weight that was given.
No, you actually figured out the empirical formula.
Ah, okay.
All right. Curtis, this problem, the thing I just highlighted,
Uh-huh.
that would be an example of a problem of this nature. You're given the molecular weight and you're given the empirical formula. You want to know what the molecular formula is.
So how do we come up with 13?
Because the empirical formula is CH, right?
Mhm. Yep.
The atomic mass of carbon is 12.
Oh, I got you.
The atomic mass of hydrogen is 1. Add up those two. 13 is the empirical formula weight.
Gotcha. Atomic mass. Okay, thank you.
Any other questions, guys? Nylon is a polymer that has a continuing repeating unit, and that repeating unit mass is 226. If the empirical formula is C6H11NO, what is the formula of the repeating unit? Basically, the empirical formula. We're given kind of what the molecular formula is. We also are given the empirical formula. We add up all of these atoms for the empirical formula. We get 113. The repeating unit is 226. So we divide that by the 113, we get 2. So the actual repeating unit is C12, H22, N2O2. Are we good with this?
Yeah, I just want to copy it down real quick.
It's in the slideshow. Chase, tell me when you're done.
All right, we're good.
Okay.
Thank you.
This is the hardest problem. Combustion analysis of naphthalene, a hydrocarbon used in mothballs, reveals 8.8 grams of carbon dioxide and 1.44 grams of water. Calculate the empirical formula of the naphthalene. Oh my God, oh my God, oh my God. How am I gonna do this thing? First of all, take a breath. Now, anybody remember what the products of combustion are?
CO2 and water.
Amazingly enough, our two products here are CO2 and water, right? What's CO2 composed of?
Carbon and oxygen.
Okay,
2 oxygen, 1 carbon.
all right. So remember, in combustion, we have a hydrocarbon plus water. Did the carbon in the carbon dioxide come from any other source but the naphthalene?
I mean, how would that even be possible?
So your answer is no, Hunter, right?
Yeah, no.
All of the naphthalene carbon was converted to CO2. All right. What's water composed of?
Hydrogen and oxygen.
All right. Where did all the H from the water come from?
Naphthalene.
Remember, we're only reacting naphthalene and O2. Did any of the hydrogen come from the O2?
No.
So all of the hydrogen in the water came from the
Naphthalene.
naphthalene. All right. Do we have a way of getting the mass percent of carbon in carbon dioxide? We just did this problem, guys.
Yeah.
Do you remember the hematite?
I was gonna say, wouldn't you do it the same way as before?
Exactly. You tell me what you're doing, Jennifer.
So you have to find the weight of the carbon in the carbon dioxide,
And what else?
the oxygen.
Yeah, you're going to need the weight of the carbon and the weight of the carbon dioxide.
Oh yeah, the carbon dioxide.
What we're doing, guys, strategy-wise, we're getting the mass percent of carbon in carbon dioxide, and we're going to apply that to the 8.8 grams. The same way, we're going to get the mass percent of hydrogen in water. Then we're going to apply that to the 1.44 grams. By doing that, we will come up with the grams of carbon and we will come up with the grams of water. First step, find the grams of our elements. Second step, once we have the grams, turn them into moles. Once we have the moles, divide by the smallest number. Same procedure. So our trick is, when we're given combustion analysis, we have to realize all the carbon from the compound was converted to carbon dioxide. All the hydrogen was converted to water. If I get the mass percent of the carbon in the carbon dioxide, I can determine how much carbon I have. If I get the mass percent of the hydrogen in the water, I can determine how much hydrogen I have. Coincidentally, if I divide the atomic weight of carbon, which is 12, by 44 carbon dioxide, I come up with the mass percent of 27.3. If I multiply that by my weight of carbon, this means I have 2.40 grams of carbon. Are we seeing this? Okay.
44 come from?
What's that?
Where'd the 44 come from?
All right. I'm sorry, this is Kaylin?
Yes.
All right, Kaylin, what's the molecular weight of carbon dioxide?
12
Plus
plus 16 plus 16.
12 plus 16 plus 16 equals 44.
That makes sense. Thanks.
So what you're doing is we're getting the mass percent of carbon in carbon dioxide. So the part is the weight of the carbon, the 12.
Okay.
The whole is the weight of the whole carbon dioxide, which is 44.
Got it.
That
Thank
gives
you.
us our mass percent. That we apply to the total weight of the carbon dioxide, and we get our weight of carbon. Okay, Tori? We have 1.44 grams of water. Tori? I want you to do the same thing with hydrogen that we just did for carbon. Just tell me how to set up the problem, Victoria.
We have to find the weight of hydrogen. Well, we have to find the whole weight of water.
Which is 1 plus 1 plus 8, 1 plus 1 plus 16, or?
So it's 18.
18. So how much hydrogen weight do we have?
Is it in like 2.16 or something?
2.02.
2.02.
So tell me what I'm going to do with those two numbers.
Divide them.
I'm going to divide them. When I divide them, I'm going to get the mass percent of hydrogen. Then once I get the mass percent of hydrogen, what am I going to do, Victoria?
You're going to times it by, I lost my train of thought. Somebody please help me because I had it in my head and then it went away.
Somebody help her.
By the
Times
one,
it by 1.44.
You're going to divide it by the 1.44. So when I have my water, I know that the weight of water in H2O is 2 grams. The whole weight of water is 18. I divide those two out and I get 11.1% hydrogen. I multiply that by my 1.44. I now have my grams of hydrogen. And it's beautiful now, guys. What do I do now? I've got the weights. I've got the weights of all my elements. What do I do now?
turn them into moles.
Turn them into moles. I got 2.40 grams of carbon. I'm going to divide that by, or multiply it by 1 mole over 12 grams. This gives me 2 moles of carbon. Okay. I take the 0.160 grams of hydrogen, divide that by 1. This gives me 0.160 moles of hydrogen. I now have the moles. What do I do after I have the moles? As a stereo, guys.
You divide it by the smallest mole?
That was a very, very thin stereo.
What?
I wanted the whole class to join in.
Oh, sorry.
Guys, steps. Keep these steps in mind. Find grams. Turn grams into moles. Divide by the smallest number of moles. Okay? Which is smaller? Armenia.
Yes.
Which is smaller? 0.160 or 0.2?
160.
So, Armethea, I'm sorry, Armethea. I've got 0.160 is the smallest. So what do I do then?
Divide it into
each number of moles. I divide it into 0.160, I get 1. I divide it into 0.2, and I get 1.25. Uh-oh, I got a fraction. What do I have to do?
Double it.
No, if I double
Times it by 2.
If I times it by 2, Armenia, that gives me 2 times 1.25 gives me 2.5. Am I good? Do I have a whole number
No.
yet?
You can times it by 4 and make it.
If I times it by 4, this means I get a 5. But if I times the carbon by 4, I have to do the hydrogen by 4.
Yeah.
So I have 5 for my subscript C, 4 for my subscript H. So my empirical formula is C5H4.
Professor, I have a question about how you multiplied, like, for example, the CO2. You divided the CO2 by the carbon.
I'm sorry?
So did you divide the CO2 by the carbon to get
No, the other way around, Chase. You want the mass percent of carbon. So if you want the mass percent of carbon, carbon's going to be the part. In this case, the whole molecule is the CO2. So you divide the weight of the carbon by the weight of the CO2. Atomic weight of carbon divided by molecular weight of CO2.
Okay.
Got that?
Mm-hmm.
Questions on this one?
Professor, I have a question.
Okay, I'm here.
When we divided 2.02 over 18,
yeah,
we took H2 because it's a diatomic molecule, or is it because it's H2 in the formula here?
You did it because it's H2 in the formula.
Okay, thank you.
If I was dealing with peroxide, I would still deal with 2 H's, but in that case, I would have to deal with 2 O's as well. Okay, Rosina? Peroxide's formula is H2O2. Okay? Guys, give me your questions.
So how do you know which one to, so like for the CO2, you divide it, you multiplied the mole by the,
No, for the
never mind, that was a stupid question. Never mind.
Chase, what we did was we found the mass percent. That was the 12 over the 44. This 0.273 is actually 27.3. I just didn't bother to multiply it by 100 because I was just going to have to divide it by 100 again.
Mhm.
I took the 0.273 and I multiplied it by our weight of carbon dioxide. This gave us our weight of carbon.
All right.
Come on, guys, more questions. Okay, we just did this problem. First one to give me the answer. The empirical formula we just came up with for naphthalene was C5H4. If the molecular weight is 128, what is the molecular formula? Extra credit point. On the line. Let's go. First person.
What was the question?
I was about to guess C10H8.
Who was that?
Curtis.
Curtis, you got it. You're starting to rake them up, Curtis.
Could you just
I'm trying.
Okay. Now, by the way, if we suddenly get knocked off here. Okay, the way Curtis figured that out, Curtis took the subscript for carbon in the empirical formula and multiplied by the atomic weight, which was 60. Okay. Next thing he did was he took, for the hydrogen, he took the number times 1 to equal 4. So the empirical formula weight equal to 64. You take the 128, the molecular, take the molecular weight, divide that by the empirical formula weight. This gives you the number that you multiply subscripts by. So 64 goes into 128 2 times. So I multiply 2 times 5, that gives me C10. 2 times 4, H8. That is my molecular formula.
That seemed a lot easier than how we explained it before.
Hunter, I'm sorry. I don't know what to tell you. I thought I was explaining it the same way each time. All right, I'm going to get out of this. I have a second slideshow that has more problems in it. What is the mass percent of sulfate in Al2SO4 taken 3 times? Okay, I haven't bothered you yet.
Oh, me?
Yeah, you.
Sorry, I'm taking notes.
I want to know the mass percent of sulfate in Al2SO4 taken 3 times.
Can I just Google it?
Can you just Google it? Yes, you can. But you know what happens if you Google it? Your Google's not going to be available on the test.
Fine. Yeah, I don't know how to do this.
Okay, that's fine. I don't know is a perfectly good answer, Kay.
All right.
Do you know what mass percents are? What did I define them as?
I don't know.
Somebody help her. How do you get a mass percent?
But out of 100 or something?
Yeah, it's out of 100. Come on, guys. How do we just get the mass percent for carbon dioxide and for water?
You first find the weights of each element.
Okay. Good start.
Don't you have to just divide like the weight of aluminum over the weight of the whole compound?
That would give me the mass percent of aluminum. Good guess.
Oh, of sulfate. I thought it said aluminum for some reason.
So you wanna find the weight of the, well, you wanna find the molecular weight of the whole compound, but then you also wanna find the molecular weight of sulfate and divide the weight of sulfate over the entire weight of the molecular compound, and then times it by 100 and you get your answer.
Okay, that's exactly what we're doing. How much is sulfate's contribution? Sulfur weighs 3206. There are 4 oxygens. They weigh 64. So 64 and 32.06 is 96. But that's not the entire contribution. My formula says there are 3 sulfates in that compound. So I have to take the 96.06 and multiply it by by 3. And when I do that, that gives me 288.18. Okay? Now, what's the only other thing left in this compound?
Aluminum.
Aluminum. So what I'm going to do there is, there are 2 of them. So aluminum's contribution is 53.96. I add aluminum's contribution and sulfate's contribution. I add the 53.96 and I add the 288.18. That's where the number 342.14 comes from. So the percentage sulfate is going to be the weight from the sulfate divided by the entire molecular weight. That ends up being 84.22%.
Okay, you're going kind of pretty quick there. So you would do you found the molecular weight of the SO4, and that's 288. And then just to find the AL, you do the same thing pretty much. You wouldn't include the 3, right?
No, you won't. Just to get the aluminum, you take the atomic weight of aluminum, which is 26.98, Chase.
Okay.
And there are 2 of them in the formula. So you have to multiply 2 by that. So aluminum's contribution is 53.96.
Okay.
All right. So I'm going to add the aluminum's contribution and the sulfate, the 288.18 and the 53.96. Add those 2 together, I get the weight of the entire molecule. I then divide the weight of the sulfate, the 288.18, by the weight of the entire molecule. This gives me the percent by mass of sulfate in that molecule. Questions, guys? We already did this problem. I love this question. A 5.02 gram silver coin. Remember, coins are alloys. They consist of silver and another metal. It's dissolved in nitric acid. The nitric acid dissolves all 5.82 grams of the coin. When I add silver chloride to this, all the silver that was in the coin gets precipitated out as silver chloride, AgCl. And the silver chloride weighs 7.20 grams. Determine the percentage of silver in the coin. Strategize it out, guys. Talk it out.
So I'm assuming you're gonna have to get just, you need the weight of silver, right?
Correct.
Okay, according to my chart, where the hell are you, silver?
It's
around like,
one down from
yeah.
goes zinc
So for,
over one and one down.
yeah. So it's, from the table I'm looking at, it's 107.9, or can we just round it up to 108?
Go ahead and round it.
Okay,
For all intents and
so,
purposes, it'll be fine.
so you have the weight of silver, which is 108. I just simply want to do 5.82 over 108 to get the percent, or times it by 100 to get the
No.
percentage of silver.
Nope.
Yeah, that's
Can't
what
do
I
that.
want to do, but I'm not going to do it. But at least I said that we have to find the weight of silver. I gave you that.
Okay. Anybody else? Rosina, Maria.
I have a suggestion. I don't know if it's the right one though.
Let's go for it, Jennifer.
So the first thing I thought of was to subtract the 5.82 from the 7.02.
You can't do that.
No.
Wouldn't we need more information to solve this? Like, wouldn't we need to know how much nitric acid there is?
Nope, don't need it. Jennifer, the reason you can't do that is part of this weight is chlorine.
Oh, because that was added in after. Okay, I see that now.
Would we just find the entire?
You got to get the
weight?
ratio of the chlorine and silver.
What? I'm sorry, Hunter. Sorry, Curtis.
No, I'm saying in the silver chlorate, we would need to get the ratio between the silver and the chlorate.
So in other words, a mass percent.
Yeah.
Curtis, is that what you were going to say?
No, I was just gonna say we find the weight of the entire compound, and then we find the weight of silver and just divide it out, multiply.
That's
by
what you
100.
were saying, Curtis.
Oh, okay.
That's exactly what we're going to do.
Okay.
We know what the weight of the silver chloride is. We can figure out the weight of silver in the silver chloride by taking the mass percent of silver chloride. As you said, Curtis and Hunter, what we're going to do is we're going to take the atomic weight of silver and we're going to divide that by the atomic weight of silver plus the atomic weight of our chlorine. And by the way, Hunter, in problems like that, you got to cut away the crap. Nitric acid does nothing for you. The only thing you need to know is that it ends up as silver chloride.
Okay.
Okay, silver weighs 107.87. I add 35.45 to that, and I get 143.32. I divide the 107.87 by the 143.32, and I get 75.265% silver. Now, Curtis, what did you say we do next?
Multiply by 100.
Okay, that's how we got to 75.265. Back to the original problem. Where are we going to apply that 75% to?
The 5.82.
Does the 5.82 have chlorine in it?
Oh no.
So which one are you going to apply it to?
It would be the 7.20.
So that's what we're going to do. We're going to, the silver chloride weighs 7.20. So we're going to take 75% of that. That is the weight of our silver. So I don't know what I was doing there. So we now have the weight of our silver. If the coin originally weighed 5.82, We just now take the weight of our silver and divide it by the weight of the coin. So we get 93.1% silver in the coin. Questions, ladies and gentlemen? I kind of like this strategizing thing. It's at least keeping some of you on your toes anyway.
Hold on, can you go back and where'd you get the 5.42?
Okay, remember, Tori,
He got that from applying the ratio to the mass.
okay, Tori, we have
Yes.
silver chloride, right?
Yeah.
We can get the mass percent of silver in silver chloride, right?
Mm-hmm.
Silver weighs 107.87. Silver chloride weighs 143.32. I divide the 107 by the 143 and I get around 75%.
Yeah.
I then know what the weight of my silver chloride is, which was
720.
720. So I then, once I have this 75%, I multiply it by my 7.20 grams.
Oh,
This gives me
okay.
the weight of silver.
Okay. I think I was writing something down and I just blacked out that whole slide. Got it. I'm good.
No problem. Piece of plumbing solder weighs 3 grams. I dissolved it in nitric acid, then I treated it with sulfuric acid. This precipitated the lead as lead sulfate. After washing and drying, it weighed 2.93 grams. All right, so all the lead is gone. The solution was then neutralized to precipitate stannic acid, which was then heated and decomposed to 1.27 grams of tin 4 chloride. What is the analysis of the solder as percent lead and percent tin? Can we determine, guys, we just did this a second ago. Can we determine the weight of lead? What happened to the lead? Where'd the lead go?
The lead went into the PbSO4.
All right, do we have a weight on that, Hunter?
Yes, 2.93 G.
So can we determine how much actual lead is within the lead sulfate that weighs 2.93 grams?
We can, if you back up to the last slide, and I can remember how to do it. When you take the atomic weights of both.
Yeah. We're going to do it the same way we did it for the silver chloride in the last experiment. How'd we do it the last time?
Curtis, this is your time to shine.
We take the atomic weight of both, and then we're gonna divide the atomic weight of 10 by the total atomic weight.
Okay, we can do that.
Then times it by 100, right?
We can do that. I did lead first, so I'm gonna have to backtrack down here a little ways. Okay. All right, Curtis, the tin weighs 118.69. Tin oxide weighs 150.69. So how do I get the percentage?
We would divide 118.69 by 150.69.
And that gets me 78.76%. So what
Right.
do I do with that 78.76%?
We divide that into the 2 point something grams. I'm not.
Do we divide it?
I'm sorry. Multiply that by the 2 point something grams.
1.27.
1.27.
So if my percentage is 78.764%, 78.764% of the 1.27 grams is going to be tin oxide. So my tin weighs 1 gram. Okay?
Right.
Go back to the original question. What is the percentage of tin in the solder and what is the percentage of lead? What did the solder weigh?
1.27.
Nope.
3.
That's
Oh, 3.
the solder weighed 3 grams, the tin weighed
2.9.
nope.
Whatever number we
Or
had.
where was it? Hold on. No, we just had it.
Yeah,
One,
whatever
yeah,
number
1.
was there.
1
One.
gram. The
Yeah,
solder weighed 3, the tin weighed 1. What's the percentage of tin in the solder?
30%.
33%.
33%. Yeah.
Okay. I'm going to go the long way. Yeah. You could say, okay, that if there's 1 gram of tin and 3 grams of solder, then 2 grams must be lead. I can understand that, but we're going to do it the hard way.
I mean,
Same thing. We have 2.93 grams of lead sulfate. We got 2.93 grams of lead sulfate. How am I going to find out how much lead is in that 2.93 grams? How did we do it before, guys?
the atomic weights, just like Curtis was saying.
Lead weighs 207.20. Lead plus 32.06 plus 64 for the oxygen. The whole thing of lead sulfate weighs 303.26. Therefore, the mass percent of lead in lead sulfate is 68.324 grams. I multiply that by the weight of the lead sulfate. It comes out to be 2.00 grams of lead. Questions, guys?
I definitely need to practice this. Will we have something coming up?
Yeah, I need to look at the conversions and do practices.
Okay, hold on a second. I'm going to stop share. And hopefully I'm going to pull up the, did you get the itch, Hunter?
Say that again. No, I'm putting icy hot on my neck because it hurts.
Ah, okay. All right, I'm going to get out of here. This is where I want to be. Okay. Are you seeing the screen that says Introductory Chem Lab?
Yeah.
Okay. You have problems in your
Homework.
survivor guide. You have problems in my lab and mastering. And if you go to the empirical formula problem,
You're in the lab, not the lecture.
oh, is that? Thank you so much. Before you leave, I got to take attendance. Okay, I'm in the empirical formula. Okay, Curtis. There's more homework down here. Okay?
Okay, sounds good.
There's extra homework beyond. There's more homework, there's more problems in the second PowerPoint I didn't get to, but there's also, if you go down here for extra homework, There's extra homework, and it does have an answer sheet. Curtis hit the nail on the head, guys. You are going to have to start, if you haven't to this point, you're going to have to start doing your homework because it's vital. That's the only way you're going to get facile at doing these equations.
Could we go back to the last lead problem? Because it asked for the percentage.
Yeah.
Okay.
Okay, this one, okay?
Yes.
Okay, you kind of understand how we got to 2 grams of lead?
Yes.
The original problem gave us the weight of the whole solder.
3. Yes.
So the weight of the lead in the solder is 2 divided by 3, or the percentage of lead in the solder was the lead divided by the weight of the solder.
Okay.
Okay?
Yes.
Anything else, ladies and gentlemen? Okay, we start stoichiometry on Tuesday.
Oh God.
Stoichiometry is easier than this stuff.
Oh, thank God.
And so I'm just looking through here.
This has a really awesome name, Stoic. It's like yoink.
Honestly, I don't know where it came from.
Professor, I'm gonna leave because I gotta beat the rain.
No, hey, class is
okay?
over, Hunter. Class is over a couple seconds ago.
You already took
I just
attendance.
don't want to be rude.
No, I didn't.
Yeah.
I did not take attendance. Omar, you here? Lewis, Christina, Gaith, Zaina, Curtis
Dana
was here.
just said her mic isn't working on the chat.
Thank you. Apple Grace,
I'm here.
Hunter's here. Marie was here.
Yes.
Chase was here. Fabiana,
I'm here.
Leandre. I did see him earlier. Armithia, I saw. Nick. Kaylin, I saw.
Alrighty, Godspeed.
Aya.
Here.
Elizabeth. Kevin. Shamira. Mariah. Aaron. Rosina was there. Andrew. Katie was there. Cash.
Here.
Hayden. Faith.
Here.
Mila was here. Jennifer was here. Alec.
Here.
Brian was here. Helen. Spencer was here. And Tori was here. Thank you, ladies and gentlemen. I will see some of you in a half an hour
Thank you.
for the mole portion.
Thank you.
Hi, Professor.
Thank you. Thank you. Feel better.
I'll be fine.
Have a good weekend.
You too.
I'm gonna go bake banana bread. I'm excited.
Well, aren't you special?
I am special. Have a good night, Professor.
Take care, Tori. Gaither Omar.